Hey everybody, this is Larry. This is contest. What is it? Biweekly 163. Hit the like button, hit the subscribe button, join me on Discord. Let me know what you think about today's contest and prompt. Just getting my what did I do? I'm getting my notebook ready. I haven't been using it that much actually, honestly. I try to put things on screen so that you could see what I'm doing. But yeah. Excuse me. Hope you that cough. Hope everyone's having a great weekend. Yeah, let's get started. I don't know that I'm working on anything specifically in terms of contest. And what I mean by that is that sometimes I'm like, okay, I work on being more accurate, slower, faster, or more slower, being more deliberate, more careful, not like just be slow. But yeah, I think nowadays I don't know if I care that much about it. So yeah, let's get to it. Biweekly 163. Let's, am I ready? Let's go. 5, 4, 3, 2, 1. Go, 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 go. Alright. I always convert these to R and C. It's less confusing. Oh, it's max. That's right. I always forget which one is this one for some reason. Okay. Quite every cell. Okay. First, of course, we will look. This is a million, right? A million cells. So we can do something funky, maybe. I mean, it's just greedy, right? Because then now, yeah. I mean, we could even create it with for loops if we need to. Is there like a harder version? No. Okay, I mean, should be just math, right? Because I think this is where it would be helpful to have, yeah, drawing, honestly, just to make sure. I mean, we can implement this and guess, but I feel like, yeah, sorry friends, it's on the grid, right, or cell. Okay, so you're given cell, there's grid and cell, sometimes it's on the cell, sometimes it's on the grid, and it's a little bit different, slightly different. So k is equal to 1 means that, okay, so that means that you want to put on 1 1, and then that covers left, right corner, right? That is 1 away, so that means that 1k covers yeah, so it covers 1 plus 2 times k, right? So let's just call it coverage. I don't know, we can afford variables, right? So that means that, yeah, it's just going to be return, or you need to round up, I think, right? Maybe I'll write this as, yeah, so it's slightly less messy, right? I mean, there's more typing though, I don't know. But it's fine, because sometimes you save 4 and 1, right? How come? Yeah, okay, 4 and 1, right? Yeah, that's YOLO. Unless I misunderstood, it should be okay. Yeah. I'm trying to be a little bit better in like not trying to shave 10 seconds to get a wrong answer and cost 5 minutes, even though I could fix it in like 10 more seconds, right? So anyway, okay, Q2. Nums ij is perfectly following conditions are satisfied. Okay, integer array nums, and looking at constraints, and there are any all range of numbers. Okay, I and j are perfect if, oh jeez, what does this even mean? I guess this is one of those, and we have to try to figure out what. Okay, I don't know what that means, right? So maybe we could draw it out. The way that I like to think about these is that we play around with some small numbers, but also let's look at the example, because yeah, okay, because the example will play around a little bit. So 1 2 ij is 1. It is a little bit confusing, but okay. So min, what does this mean? So min of either the delta or the sum. That's interesting. I don't know what that means, but and then you have the max of those two. So it's between the, no, what? Oh. So the smaller number is, I don't know. This is a very difficult to read point. I mean, maybe it's the solution may be like 5 lines of code or something, but it's just, for me, a little bit confusing. Okay. I mean, okay, so I mean, the general idea, I still don't know how to solve this, but given that this is 10 to the 5th n, basically we want to process one number at a time and then maybe do a loop through all these things, and it's just case analysis at that point, right? So basically, for example, we can break down the min and the max, meaning that, okay, so yeah, so we given x, where x is the number we're processing, then we just look at the numbers in which a is x and then b is x, right? Or maybe that's maybe better thing is that min of AB is equal to x, and then max of AB is equal to x. So we kind of divide them into two scenarios, right? So basically, this is saying that the past number is bigger or equal. I won't say or equal to, but we have to worry about dedupes with the max as well, right? This is a really, because you're basically trying to separate it out so that you could process all this in one go, right? This is just too much thinking. Okay, for Q2 I mean, but okay, the past number is bigger or equal to, okay, well, so what does that mean? That means that x is, that's just, yeah, okay, I don't know. That means that b is bigger, or let's just say p is bigger than x, the previous number, right? Maybe that's a little bit better. Okay, so then p minus x, because it's going to be greater than 0, right? Is that true? Yeah, because by definition we said it's going to be bigger. P plus b, can it be? The thing is, both these numbers can be negative, so it can be really small. So you can't just say that this is going to be bigger than the other, or the previous number, they both may be positive. They're both positive, then it's going to be really big. So you can't really generalize the min and the min-max relationship, huh? I mean, we could do case analysis, but there's like 8 cases or something. I don't know, or maybe just 4, 8. I don't know. It's just way maybe there's only 4 cases. This is always true, and then it's just either this is always true. Yeah, okay. Because I'm trying to figure out this part, right? So we don't have. So then it becomes, without the absolute value. And a plus b just could be anything. But we can, okay, so that part, we're searching for numbers. This is just annoying unless I'm like overthinking some easier trick. Okay, actually one thing that we should do is sort. I forgot. Okay, let's just say we sort them, because ij doesn't matter. Then now we only look at previous numbers, which are all smaller. Yes, that's a little bit better. Okay, so then now all the previous numbers are smaller. So that means that we don't have this scenario, okay? Right, so that means that p is, the previous number is less than or equal to the current number. Maybe that's a little bit, so we don't have to worry about this. That means that here, this is going to be the previous number always, because that's going to be min, and the max number is x, right? The current number we're processing, and then this is the previous number. So I mean, this still is fine, but this just becomes x minus p because it is the smaller number, and then the sum of these, right? So then now we can do case analysis, maybe? Man, I am spending a lot of time on a Q2. I don't know if it's just me, but I mean it's binary search, but I'm trying to figure out the exact binary search, right? Like I don't have any trouble with what I need to do, but it's just the math part. Okay, so this number is always positive, right? This is the current number, this is the previous number. I don't know how to separate these. I mean, the idea is that you cache not the p, but some function of this. You probably have to cache two functions in which well, let's just write x plus p, but it's a little bit nuanced, right? Because then now the min function is just a weird function, right? But let's just say we add plus p on everything, right? So that's plus p, this plus p, and then this plus p, but it's outside of the thing, maybe, right? Because this is absolute value. Can I absolute value the components? I guess not, because this could be, one of them could be negative, then you don't absolute the value. How do you? I mean, okay, so there are really only two scenarios, which is, and maybe we should go for it. X plus p is greater than equal to 0, then it's just min of x plus p, do, right? And then this, of course, is just equal to two scenarios, which is whether p is greater than 0 or not, right? If p is greater than 0, then you have x plus p, oh, because if it is greater than 0, oh, no, okay, well, if it's greater than 0, then min is x, so you have x to the p plus p, right? But if p is less than 0, then this chunk is smaller, so you have x minus p less than or equal to p plus p, and then you add the p plus p on both sides, so then now you have x is less than 4 times p. I don't know, right? So we have to process every numbers like this, and then we could do it this way, maybe, right? We also have to kind of do this math, right? This is such an annoying problem. How so many people got it because I cheated and looked at the user accepted. It's a good amount. A lot of people got them way fast. I don't know how. Oh well, unless it's cheating. I don't know. Maybe I'm missing something obvious though. I mean, it's very possible. Okay, case analysis. Let's go. Okay, so you have this, right? X is greater than or equal to p. Okay. Wait, is that the case? Or oh no, this is always the case because we sorted. Yeah, okay. Okay, so then now we have x plus p is greater than 0 or equal to 0. Then that means that we have max of x plus p. Well, if we have this function, if p is, did I mess up a thing? No, I did mess up a thing, didn't I? Well, I missed a case in which we have to figure out what x is, and if x plus p is less than 0. All right, let's go through this first. If it's less than 0, then what happens? I don't know. This can't be right? I feel like I'm like, this is a ridiculous solution to do. I mean, you could do it, but I feel like I'm missing something. The sorting doesn't really, I mean, it does simplify for sure, but then you have all this craziness. Alright, let's take a look at the examples real quick. You have -3 and 2, min. Oh, I missed this. It's min of the absolute value, not, oh snap, that's different. I missed that. How did I miss it? Okay. I mean, I don't know if it's right, but it's different. Or I don't know if it changes anything. Oh man, now to redo this. Oh, that's annoying actually. Okay, well we still, let's see. Maybe that makes it easier, so, you know. And we use our notation of x minus p. We know that this is already x is greater than or equal to p. This is xp, right? So that means that, and this depends on whether, that's annoying too, right? Like it's not a binary search the way that I want to do it, but, and I always spend like more than 10 minutes just struggling on this one. Like, I mean, I could case analysis it, but it's just so many case analysis. I'm struggling to believe that that's what everyone did, you know? I mean, and did it so quickly. Let's see. Okay, so x is minus p, we know that is true. There's something weird about this relationship that I don't know. X plus p, what does that mean? How do you search for it in a good way? That's what I want to know. And then the max and the min. Like, maybe a lot of it is just not possible, but I don't know how to figure it out. I'm gonna come back. I feel like I'm spending a lot of time on this. And people, I mean, I can't stop looking at the leaderboard. It's just silly. I don't know. I don't want to go forward yet because it's just like I take a quick peek and few people solve the other two. But how am I stuck on Q2? Like, you know. Do we just process things in a weird way? Okay, so let's say x is the min. But then you have to take care of the max, which is the other number. So it's like some sort of case. I don't know. What am I doing? And again, maybe you could do some. I need to draw. I think I need to see this more visually. That's how. Okay, I'm just going to draw in a notebook. Maybe I can't do it in mathematically or whatever, but I need to draw it out. Okay, so let's say we sort that. We have -3, -1, 2, 4. In fact, whatever, right? Maybe we do, maybe we don't. But we need to, what I can do, instead of drawing it out. What is a perfect pair, right? So maybe it's like if I draw it on a 2D plane, what will it look like? I think that's the thing I want to know, right? Okay, I was going to write a brute force version, but I actually want to do something a little bit different. I'm going to put this in a paste pad somewhere so I don't lose it real quick. Okay, so then now I want to do like something like something like this, right? So if if min of like I just want a visualization. I think that's what I'm trying to do. Okay. Okay. I guess you could just return this. I have to change some code. I obviously copy and paste, and then match up this. Okay. Right. Oops. I guess this is actually too big. Maybe it prints too many things. Oh, that's not right. Did I mess this up? That's definitely not right. What am I messing up? Min of a minus b, a plus b. I can't even do. Oh, whoops. Though maybe 1,000 is too big to start off with. Let's just. Okay. It's okay. One number is 100, negative 100. It goes to negative 50. Right? I guess that's how. I mean, they just kind of. Okay, negative 100 goes from 100 all the way to negative 50, and then 50 all the way to 100, or I assume, or to 99 maybe. Oh no, it's just that we don't. Larry, Larry with the dubious patterns. Okay, fine. Right. Maybe this is. Maybe I should have done this a long time ago. Okay. I mean, it looks like it's just the one number has to be half the other number. I guess that's the short thing. We sort them, right? So it's gonna be maybe we sort by the absolute value. Does that help? The a plus b part is still confusing to me though, so I don't know if that's quite right, because I mean I know that this goes to negative 50. Okay, 98 goes to 49, and 100 is. How big does it go to? I guess it should go to up to twice as much because of the other side, right? So okay, I guess that's not so bad. Once you see the pattern, it's not so bad, I think, to implement. Let's say 65, we have 33, and does it go? Well, it only goes to 100 because that's what we have. So all right, let's try one of the numbers to be smaller, and then we can see, and it should only go up to 60 from the other side, reciprocal or whatever you want to say, right? So yeah, negative 60, even though it goes up to 100, so it goes outside of range. Okay, so I mean this is pretty straightforward to implement now that we see the pattern, and yeah, apparently the pattern you can't really figure out analytically. I couldn't figure it out analytically. So yeah, so then now, is it true that the numbers don't matter, or is it just absolute value? Right? Wait, let me. Meaning that we could process this by the absolute value, right? And you could do like a sort sliding window thing, but or 2 pointers, not sliding window specifically, but yeah, I think like you get absolute value for each one, right? So maybe yeah. So nums x for x and nums, right? So something like this. Let's just put it in comments in case I need it. I mean, I guess it's pretty straightforward. But for x in nums, p is equal to yeah, okay. No, I was going to write it differently, but okay. So then p dot append x, and then we just binary search left is equal to so it goes up down to half. Wait, I guess that's why we kept it here. I know that it goes down to half, but I forget if it rounds up or round down. Like, okay, let's say we have 29, we go up to so it rounds up. Okay, I actually also want to confirm this on the other side because we've been doing it on the negative numbers. Let's just say 10. So yeah, well, 10 will be round up. So 11 rounds down to 6. Okay, so we, okay. Yeah, okay, fine. I mean, I took a long time on this, but apparently people could either do the math better than I can or something. But yeah, then now we have p dot bisect left, left, x round up, right? We have, let's search for p. We want this lower bound, right? Yeah, and then right is equal to bisect that bisect right, p 2 times x. Yeah, and we want to be inclusive, so it's bisect right, and then it is just count to the right minus left. It doesn't include the right, so it should be okay. Yeah, okay, something like that, right? We have 240. All right, let's go. Okay, that was a tough one for me anyway. I don't know how other people did it. I should have done that earlier, visualization. I was talking about it, but I didn't know how to do it. What time is it? Man, 25 minutes for that one, or 20 something minutes on that one. All right, focus. Let's go. We got it. All right, weighted edges, direct edge. Okay, we have a directed weighted graph. Each node has a switch that can be used at most one. And not use the switch when reverse. You may actually incoming edges and reverse the, and each node can only do it once. I mean, it's just regular Dijkstra, right? Let's see. If you reverse an edge, basically, I mean, it doesn't matter. You will never come back because you're already at Dijkstra. So it's Dijkstra, right? And that's as negative. Wait, no. So it's just regular Dijkstra. Okay. This is actually way, to me, easier than the other one, just because it is. Like easier than Q2 just because it is standard theory, right? And I say that, I don't know, I've been watching a lot of chess, so I feel like I'm like using the chess language a little bit. Okay, yeah, where am I going? From 0 to node minus 1, so yeah. What am I doing? How am I so bad at this? I am rusty, as you can see, because I should not hesitate on how to write Dijkstra, but it is what it is. I think that's all I need, though. Yeah. Distance node equal to. I am very rusty. Like, I feel like this is automatic. If otherwise. All right. And technically speaking, even if it is T, no, it should be fine. Okay, focus for W in. I mean, we have to make modifications. I'm going to make the modification soon, but for now, let's do this. So we have to add some. Oh, this is just wrong, actually. Actually, no, maybe this is right. Maybe that is how I do the modification. You just times W, right? You would only, yeah, for Dijkstra greedy, you would only be on a node once anyway. You would never reverse more than once, and you would never leave from the same place twice. So I think this is fine. Okay, so then now, yeah, I mean that's good. Yeah, okay. If weight is less than best of 3, oops. Yeah, best of 3 is equal to okay, and then heap We best of nope, get away, you noob. Okay, right, and then return -1. Otherwise, if node is equal to n-1, return d. Why am I saying best of node? Whatever. Okay. We have 5 and 3. Hopefully, why does this keep changing on me? I always went in this view. YOLO go. Okay. Yeah, much easier. I mean, it took me 22 minutes to try to figure out that one and 4 minutes on this one. How much time do we have left? I guess an hour. Right? We have 29. We're at 29 minutes. Already. All right. 500 people solved this, so we'll see if I can be one of the 500-ish. All right. Again. All right. Let's just wait. All right. Top left, go to bottom right, straightforward so far. Normal move, down and right, just like regular DP. Teleportation, IJ, such that grids up. Oh, we have a grid. So basically, the idea is that you cannot construct this graph. Oh, maybe. Well, you still can't, because that's what 6,400. So you do that square, that's 880 to the 4th, which is probably too big. So you can construct all this graph together, right? Otherwise, it's just regular dice draw. But you got DP. And DP doesn't work. Directly, maybe it actually. I think DP works, but you have to be careful of the edges. Okay, so it's just about trying to figure out how to do the implicit graph in an efficient way. DP is on X, Y, and K. Well, no, you wouldn't do a DP. You still do Dijkstra. Fine. Okay. So Dijkstra again. That's a little bit. I mean, because we did Dijkstra for Q3. Now you still do Dijkstra. Okay. I think Dijkstra is fine. You have X, Y, K. The states are fine, and K is 10, so it's not even that big. But then the question is, how do you figure out how to get to all the other places? Well, teleport. Oh, you have to do you have to sort grid, right? Some sort of like union find E things, right? So you go from okay, so you go from a smaller or equal to number. The thing is that if you're the current cell, okay, it's not that intractable, because the thing is that you would only, in a Dijkstra kind of way, everything is greedy, so you would maintain all the cells that you can go in things. I think about this, because basically you want to amortize it out, so because you never visit, but it's like a 2-pointer thing, right? So you use a Q for each one. 80 times K, that's the number. Well, you have K Qs, each one with all the cells sorted by the cost, and then you just kind of pop it off the beginning, depending on your current K. Okay, that sounds reasonable. Okay. Yeah, I mean, how much time do I have? That took only 3 minutes to figure out. The implementation may be tricky, but we spent only like 4 minutes figuring about it, so not so bad. Okay, yeah, I mean, implementation may be tricky, but yeah. Okay, yeah, so okay, yeah, okay. Okay, yeah. So let's just say cells. So for I in range of for J in range of C, we want to say cells dot append grid IJ. Yeah. I mean, I think the reason why I'm thinking is that I don't remember if I can just do this for this one, right? Like, does that make a copy of the tuples? I hope so. We have to test that. I actually don't don't know that I know. Maybe this is fine actually. I don't know if it's k or k plus 1, so let's just do k plus 1. Yeah, and then maybe I would say q of 0 dot pop left, and then now print q is equal to q of 1, right? It should not be if this is correct. So okay, so it's false. Maybe we can print it out real quick. Oh well, that's I messed up. Should be this, but we can print this. I just want to see if they overlap in memory, because it's a very easy mistake to make. And I am a noob. Okay, so yeah, it looks okay. I forgot to sort though. So, but that's fine. Yeah, let's see. Yeah, okay, so this is after the first one it pops. Okay, so this is what we want. Okay. How did that take 3 minutes to write? But okay, what am I doing? Okay, I have to double check whether I want it forwards or backwards. That's what I want to do. I need like a to-do list. Okay, because we can go to the smaller ones. Okay, so that's fine. Yeah. Okay, so we're good. We're Gucci then. Then yeah, this is just literally the same code as Q3. Not literally, but we have best if you go to times C for k plus 1. K plus 1. Maybe. No, I think it's k plus 1. It's fine. Yeah. Okay. And then we'll write it backwards, and best of 0, 0. We have k moves or k teleports is equal to 0. Set up a heap, and we want to put cost 0, 0, 0 k. What is the tiebreaker? I guess it shouldn't matter. Okay, yeah, okay. Like, I wonder if there's a tiebreaker that I need to care about. Maybe I'm wrong on this one, but anyway, d x y k. Current k just in case. Okay, and then if best of x, if x is equal to y, oh nope, minus 1, and y is equal to c minus 1, then we return the d. Actually, I guess maybe this. I mean, it's greedy. I don't think it matters, but I sometimes it's a little bit more particular. Okay, so then now this is straightforward up. Or not? It's not up, down, left, right. You know it. Honestly, the funny thing is that it doesn't even matter. I don't. Yeah. Okay. This one can go to any distance, not just up, down, left, right. Okay. Huh, that is interesting though, actually. Right, so you have someone like that, right? So you have for dx dy in direction. This part is pretty straightforward. Or I've done this maybe a million times and I still get it wrong all the time, but still should be pretty okay. Okay, ck remains the same, so it is going to be best of nx and y ck. If this is greater than best of, technically just the d, right? Yeah, d plus. I don't like it right with d though, because sometimes I mess up. ck plus 1, then oh, the cost of teleport is 0, so you could, it's like actually I messed up a little bit. I use heap. This could be a 0, 1 q. Do I want to change? I mean, I'm gonna write it this way because I'm a little bit too late to change, but let's put a note. Oh, kind of on the heap. I mean, it's not too late to change, but I don't want to rethink stuff. The only thing I worry about is that it might time out. But yeah, okay. So right. One and then I maybe I could have thought about it a little longer, I suppose. Yeah. Okay, and then now we have to do the thing where yeah, while length of q of the current k. Yeah, I think that makes sense. Yeah, and the cost is 0 anyway. So maybe I did this. I don't know. I didn't really think about the. Yeah. I thought that. Yeah. I don't know. I just didn't think about it too much, honestly. Okay. So the previous cells. Oh, that's the grid x, y. So while this is less than or equal to. So we did. No, what are you doing? Well, the value is on the q, but maybe that's fine. I don't know. I like to reuse things on the source, but grid of xy, then q of ck dot pop left, and then we do best of nx and y, or not nx and y. Okay, so nx and y is equal to q of ck of 0. Oh, we have to do this before we pop. And the first is the D, or the grid thing, which we don't care about. We pop left, and then now it is just the same thing as before. We just do. This part I'm with happy face. Okay, right, and then that's it. Return -1 if we never reachable. Is it always reachable? I guess it should be always reachable. Yeah, okay. Int does not support. Did I mess this up? Best oh, oops. Tuple and int. Tuple and int. Oh, wait, no. This is a tuple. Oh, yeah, of course it's a tuple. It's the beginning of the queue and then the first item on the queue. Where am I failing? 36. Oh, wait, oh, C and C. Oh, I didn't bounce. Also, I messed it up. I count up, so I am messed up. Also, I never update CK, so I'm just way messed up. This is right. Actually, this part is fine. Then why is it going out of bounds, actually? I never update CK, which I should, actually. I messed that up. But let me write a thing. CK, but I want to debug why this goes out of bounds first. C. Huh? Why it goes out of bounds? The current k is going to be k. We have k plus 1. Oh, I did my indexing backwards. Okay, I am done. Okay. Whoops. Okay, maybe it's easier to just rewrite this part because I did intend it to. It also be okay. Okay. We have 3, which is wrong. Oh, because we didn't update K, that's probably why. Okay, but at least it didn't crash. So then now, if CK plus 1 or minus 1, and because we want to go right? We also want to check if CK is greater than 0, because we don't want to go to the negatives. Okay, we still, this is still 2. Why is it 9? Oh, did I get the cost wrong? The cost is the, okay. So Daishu is actually reasonable now. Okay. The cost is, oh, I also added plus 1 for some reason, even though it said it is free. So, okay, so that part we can make cheaper, but then now we have to make this part the destination cell, so grid of n, x, and y. We have to update this. So, okay, easy fix, and luckily we didn't need, well, I don't know, we don't have to use 0, 1 grid, which okay. Remove that comment, pretend you didn't see that. We have 9, oh no, that's for the second one, 14 and 9. Why 14? Dun, dun, dun. Do we also start at cost 1? No. So we move down, 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 down. Ooh. Down again, or to the right, which is 5, okay, and then teleport to there. The cost is free, but it just needs to be, okay. That sounds right. Just double checking my things. Very easy to make a typo. Alright, let's print it real quick. Okay, 0, 0. CK is, okay, we have 2 moves left. We go to the same spot, but 1 move left and then same spot. Okay, so I'm guessing that this part, it activates itself, which is fine, maybe. But then now it goes to 1, it should go to down, so 1, 0, with a cost of 2, which is true. 14 is way too high, and then it should go to the right, so 1, 1 should have a cost of 7, which is right. But this goes to 14, why? Alright, let's see what this part is doing. Am I doing it wrong? Connecting CK, XY, NX and Y. Okay. So 1, 1 should connect to 2, 2. So 1, 1, 2, 2. Did I mess this up? No, this is... should be right. Oh, this is -1. Okay. I guess I missed a -1. Okay, 7, 9. Okay, let's remove some print statements. There was one more, right? Okay, there. I forgot I should use this. 7 and 9. All right, let's YOLO. I mean, overall, I guess if we time out, that'll be a little bit sadder, but not too bad. I think there is an optimization I can do. Oh, 9 seconds, a little bit tough, but we got it, so whatever. Doesn't matter, AC, right? But all right, I mean, not too bad. An optimization is that you would also the queue like if a cell is I don't know if that's true actually. I don't know. Like I mean you definitely could optimize it so that if you've been into this place, like if you've been here in fewer steps with more CK, then you could like eliminate some stuff or something. But I don't know that. But it's fine probably. It is way tight though. Can I do a little bit better? I think these things you could maybe change it to be a little bit better. Because the thing is that this makes it so that you teleport back and forth a little bit, which makes it visit all the states. I mean, we're done by the way, but I'm just trying to think. Maybe 9.6 seconds is a little bit scary. I don't know, what's the max one time. It used to be always 10 seconds on Leetcode. I don't know anymore. But there's this like ping-ponging, teleporting thing where it just goes back and forth, which is not what you want because it visits all the states. Even a lot of states that won't give you the best result necessarily because you've been running back and forth unnecessarily, right? Like you could get to the end with 0k or something when you could have also gone there in less time or some or less k. But I don't know. I'm still trying to think a little bit. Like maybe like here maybe we can write something like, I don't know, just to speed it up. And I don't know that this is quite great honestly, but maybe like I don't know, nk is equal ck minus 1 minus 2 maybe, all the way to 0. We just kind of hack this to be this, right? And it will prevent a lot of random states from happening, right? Let's see. Like maybe it'll get, I don't know, maybe it still kind of happens, but you could see that at one time already cuts by half because we just cut off a lot of states. So okay, like if I had 5 seconds, I would have been pretty happy. And this isn't quite thing because there is some like symmetric thing, but so I gotta stop running money. But yeah, I mean, with 5 seconds, I am much more comfortable and happier. Because these are all basically what we're doing here is that we're saying all these things are not possible, or maybe we just kind of already did it, right? Like you could, like I said, you're just trying to get rid of the case where ping pongs back and forth, and as a result, you visit so many states in a way that doesn't really change anything, or won't give you the optimal result that you cannot get in a normal way. But yeah. Anyway, cool. That is all I have with this one. Let me do a quick retro. I mean, Q2 for me was the hardest one because I was just struggling until I got it. And once I got it, it's not so bad, obviously. With you could see the for loop, and it's kind of, the pattern was kind of obvious once you look at the thing. I don't know. But was it even my longest problem? I think it is. Q3 was 4 minutes. Q4 was less than 20 minutes. So Q2 was definitely my hardest problem. And I didn't look at the name, so I was I just kind of assume everyone on top cheated, but I would not assume KMJP cheated, so maybe I could have looked at that for inspiration. Definitely very quick though. I mean, I'm not surprised Q3 was quick for him, or Q4 really. Like I got the idea and like pretty quickly. Oh, I didn't know you could click on it while I have a contest going on. Very weird design decision by Leetcode. But in any case, yeah, I wouldn't expect him to be cheating. And so finishing 4th is very, very impressive. Yeah, but also like not surprising. Like probably just yeah. Oh, I actually did it do it with DP. I huh. Don't know what to say. I mean, maybe his DP does look a little bit different than how I structured it. And maybe it is a lot faster. I don't know, because it gets rid of a log factor. Q1 was okay. Q2, like I said, what hardest one for me until I put. I mean, the pattern is very obvious, and then just binary search. Q3 is a standard theory, and then Q4. I thought it was standard. No, I mean, actually, I don't think. Yeah, I think I got it mostly right. I mean, I had some minor things like I forgot that this is the thing, but the algorithm was pretty much straightforward. I mean, I didn't even look at that part correctly. This part, maybe you could say I could have optimized it a little bit before submitting the first time, but I think the idea is still right. It's just maybe it's a little bit more efficient. For the bigger cases with respect to just the number of states you have to process through. But yeah, no, that's it. I think that's all I have though. Let me know what you think, everybody. Yeah, that's all I have. Thanks for watching. Stay good, stay healthy, to mental health. Have a great rest of the weekend, everybody. I'll see y'all later and take care. Bye bye.